Algebra 1 to 8.6b. We're doing systems of equations, and these are word problems for how many coins. When solving money problems, there's only two units, dollars and cents. That's if you're in the US. Just make sure to use the same unit throughout the problem. Don't start with one type of unit and then accidentally switch to another. So we can use a system of equations to find the number of coins in an amount. If you have an X amount of dimes and Y amount of pennies and it equals 51 cents, we can try to figure out how many dimes and pennies we have. Now you may want to think that you've got 5 dimes and 1 penny, but what if it says there's 7 more pennies than dimes? Well, then we'd have 4 dimes and 11 pennies, because 11 is 7 more than 4, isn't it? Then that would be 51 cents. Well, we can actually solve problems like this using the substitution method. So, Emma has some nickels and some dimes, and the total value of the coins is $1.65. Now there's 12 more nickels than dimes, so how many of each type of coin does she have? So we're going to let D equal dimes and N equal nickels. Now remember, it's going to total $1.65. So we can write an equation for the number of coins she has. There's 12 more nickels than dimes, so dimes plus 12 equals the nickels, because the nickels take away 12 would equal the dimes, see? It's the inverse. The value of her nickels is 5N, because each nickel is worth 5 cents, and the value of all her dimes is 10D, because each dime is worth 10 cents. And because we're dealing with cents, it's going to total 165 cents to keep the units consistent. So we're not going to mix cents with dollars. We're going to stick with cents. We can write an equation for the value of the coins. So we wrote an equation for the number of coins she had. She had 12 more than the dimes for the nickels, right? So now we're going to write an equation for the value of the coins. And that's going to be 10 times the number of dimes she has plus 5 times the number of nickels she has is going to total 165. So now we have our two equations. We have our system of equations. We've got D plus 12 equals N, and 10D plus 5N equals 165. Now we can substitute D plus 12 for N in the second equation. We can actually take this part of this equation and substitute it for the N there, because it equals N. Now we've got 10D plus 5, and instead of the N, we've got multiplied by D plus 12 equals 165. We have to do the distributive property here, don't we? So we get 5D plus 60, see? So now we've got 10D plus 5D plus 60 equals 165. We combine all the like terms. The 10D and the 5D can be combined, can't they? So we get 15D. So we've got 15D plus 60 equals 165. Now we need to isolate that D, right? So we have to start taking things away and making zero pairs. So we can take away 60 from each side, create a zero pair here, and 65 take away 60 is 105. Now we have 15D equals 105. We divide each side by this coefficient D, and we get identity property invisible 1, 1D, because 15 over 15 is a 1. So D is equal to 7. 105 divided by 15 is 7. 15 times 7 is 105. See, I tried to do 15 times 8 and it was too big, so that wasn't the right one. So I tried 15 times 7 and it came out perfect, see? So you don't always have to use division. You can use multiplication because it's the inverse, right? So now we can just plug in D as 7 into the first equation. D plus 12 equals N, so 7 plus 12 equals N, so 19 equals N. So now we know that D is 7 and N is 19. And we know there's 7 dimes and 19 nickels. When we plug these into the equation, we have 10 times 7 is 70, plus 5 times 19 nickels is 95 cents. And 70 and 95 equals 165. So it worked. It's true. Just remember to check to see if the answer makes the equation true, and you'll know you did it correctly. And when one of the equations equals a variable, we can use that equation as a substitute for that variable. So we could use D plus 12 equals N in place of N. And remember to keep using the same unit of measure or value for the entire problem. If you start dealing with inches, don't switch to feet. Keep everything as inches, okay? If it says 5 inches and 2 feet 3 inches, change that 2 feet 3 inches into all inches, okay? Try to keep the same units of measure. Now our next video, 8.6c, is word problems for price of admission problems. And if you want to link to any of the previous videos, they're going to be in this description. We just did sum of digits, the sum of two digits in a word problem in 8.6a. So if you want to go back to that one, you can see how we solved that one. And I will see you, and we'll figure out the price of admission for tickets and how much they cost and how many tickets you can get, okay? I hope this was helpful, and I'll see you there. Bye.